All right?
Excuse me, sir.
Oh,
Yes, Chelsea.
When you get famous on YouTube,
yes,
you
sir.
can give me half of the check, please.
you love money so much.
Funny
You need to start your own channel.
Sir, what subscribers have?
Not a lot, because you haven't subscribed as yet. But either way, we're going to start class now. And
Sir,
Okay.
Andrew is trying to log in, but you're not getting through.
oh well, I mean, we can't wait too long because this meeting is going to be a little bit short. So we might have to create a new meeting so you can log on again. All right. So we need to proceed. Now,
Yes,
today
sir.
we want to talk about forces. All right. And these are the objectives that we want to capture.
Wait, sir, what was taught in yesterday's class? Better.
So we started talking about scalar quantity and vector quantity. Right. And in one of
Or
the,
revision.
let me see if I probably can bring it up. So yesterday we talked about vectors, and I think we made allusion to the fact that force is a vector quantity, right? Don't watch your handwriting. So we made mention of force yesterday as one of our vector quantity. We also highlighted that vector quantities are quantities that have both magnitude and a direction. So whenever we measure force, we'll get a value. Take for example 30 Newton. Then now we're going to get a magnitude. We're going to get a direction, which would be probably. Hey, stop right on my screen. Erase that. All right. So we're going to get a direction. So we can say upwards, downwards, and the list continues. All right. So that was what we're talking about yesterday. But for today's class, we're gonna zero it down to force. So we want to define the term force. We want to differentiate between balanced and unbalanced force, and we also want to investigate situations in which forces act and draw conclusions about the effects of unbalanced forces. All right, so let's begin. So to begin this class, you're seeing some images on your screen, right?
Yes, sir.
So what is happening with the first image here?
In pushing to something.
He's
Sir.
pushing the shopping cart.
The trolley.
Yes, he's pushing a trolley.
The shopping cart, actually.
So
So the
let's
types of
highlight the
forces
word
push, pull,
pushing.
and twist, and that's demonstrated in the.
All right, Jabari.
What was that, Jabari?
So there are 3 types of forces: push, pull, and twist, and they're demonstrated
One step
in
at a time,
the
man.
picture
One
right
step at
there.
a time. One step at a time. Number one was this one, right? We talk about pushing. Good. So that's the first one. The second one.
Yes, sir.
What is happening here?
Twisting.
Twisting.
No? Sir, it's
Ringing,
twisting.
sir.
Well, ringing and twisting. Yeah, I know you say ringing. But it's actually twisting. Good? So for persons who wash their clothes, right? You actually apply this type of force.
Nope.
Unless it's the washing machine does it for you.
Yep.
But
Yes,
then
sir.
Machine does it.
no, number 3 is which one?
That's a pulling force.
Pulling, sir.
No, what I want you guys to do.
No. No.
All right, guys, let's focus here. What I want you guys to do now is to write a definition for force.
Sir, right now?
Of course, in the class here now. This thing, you one of them make it
No, sir.
class. So we're gonna write that definition for me.
Sir, hold on. May I go for my book?
Write a definition.
Sir, hold on.
Now wait for you.
Sir? Wait, sir, write a definition.
For the term force.
Sir, what you have here already?
You don't know about that.
Sir, you 14.
Me never give you that definition.
Sir, let me tell you. Let me tell you my definition.
Well, wait, man. Wait, how's you think? So you write it yet?
Yes, sir.
You not write it yet, man. We not go through the textbook. Have you know see happen on the textbook, let me know.
No, sir. We have out of my head, me back down. I mean, I have a
Push, pull,
book
and
with me,
twist,
seriously.
sir.
That's not a definition, really. That's just you listing there. Whoever said that a while ago, that's just listing. And anyhow, you put that on my exam paper, you will surely not get the full marks.
Are we getting an exam?
Don't worry yourself. Exams will be online, so don't think you're not gonna get exams.
What if I don't log in?
What?
Sir, we're going to get
Everybody can
exam
What if I don't log
online,
in,
sir.
sir?
You don't get a grade.
Sir, we're
Yeah,
going to
I
get exam online.
Of course. You think it's a free for all thing?
Of course.
Yes, sir.
Oh,
All
sir,
right, sir.
because they would have been
Back to
wicked,
class now. Back to class now. We'll finish talking about that. Next time we'll talk about that. But we need to define term force. Brian,
Sir, what I said, forces.
no, force, not forces. Just define the term forces. Based on
Yes,
what?
sir.
Yeah.
Hello. Sir, today I was, sir, the 23rd.
Yes, ma'am.
Sir.
Yeah.
Okay, I'm telling you my meaning. A force is a push, pull, or turn. It is measured in newtons.
Okay. That's good. But you have said it in such a way that I want you to add a little bit more to it, right?
Me, sir.
Go ahead,
Sir,
please.
Sir, so a force is a push, pull, or twist exerted by an object, sir, and it's measured in.
You see, I use the book.
Yes, that's the book definition.
No, for real, not even have a book.
That is the book's definition.
Let me see it,
All right, guys. Here what now? We have to kind of raise our hands.
Sir,
Yeah.
sir, you can tell them to mute their something because when all of them talking, I can't hear you.
Yeah, exactly. That's what I'm going to ask you guys to do. Don't leave the thing on. Just kind of raise your hand. I'm trying my best to see if they can see when you guys put up your hand. All right. Somebody raise their hand. Let me see if it will pop up on my screen. All right, good. So Rihanna raised her hand. Good. All right. Rihanna, what are you saying now? All right, good. That's a test. Now, anybody's want to add a definition per se? Anybody else? So as what Pingy said, a force is a push, pull, or twist that is exerted on an object. It's important that we make mention to what the force is exerted on. It's exerted on an object. So Mr. Brian, you simply put it as a push, pull, or twist. And that was somewhat incomplete because you want to say that you're exerting the force on an object. Copy that? Yes, Chin, go ahead.
Sir, you can repeat what you said a while ago, sir?
Yes, I'll repeat it for your purpose. So a force is a push, pull, or twist that is exerted on an object. Full stop.
Okay, sir.
Sir,
Yes, madam.
sir, can I repeat everything because I kind of just joined, sir.
Well, you get troublesome, my friend. Why you just join class? You're always late
Sir,
one
because
class.
I was trying to get in, sir, but you're not accepting me, sir.
No, but I shouldn't be accepting persons, meaning everybody can join in without me telling them to come in. You understand?
Yes, sir.
All right. Now, I'll repeat the definition of a force. So a force is a push, pull, or twist exerted on an object.
Sir, I'm not hearing you.
I'll write it on the screen for you.
No, sir. No.
No, I'm sure you can read. You're going to be able to. You're going to read this. So a force is a push. Pull. Hey, come on, guys! Don't write on my screen. Somebody undo that for me, please.
How do you write on the screen?
Exactly.
Excuse me, sir.
Yes.
Is that your background?
No. No. Hey, guys, you're not supposed to be watching TV now, no?
Exactly. The echoing in the background.
When if you go like when they are school for real, you know.
So
Oh,
here
yes,
we are now,
shut up
guys.
then.
So this is a definition here for persons who didn't get to see it. Now I need to move on to another page very soon. So just take that off quickly for me, please. Can I move on now?
Yes, sir.
All right. Now, here I am using a software here.
Yes,
Right. Now, some of you guys probably have seen this thing in the group where I posted a link and it will to this page. Right. Now, what I have here is basically almost like a
detail.
I didn't hear that.
Hello, can you please mute your mics when you're not talking or when there is talking? Because when you're talking to somebody else, we're hearing it and your background. So can you please like mute your mic when there is talking?
Thank you, Farm Captain. All right, no guys.
You can mute people, right?
Yeah, but I know that, but I can't bother to go and do all of that right now. All right, guys, go in ed mode quickly for me, please, and click on that link, that last link that I sent you guys. I hope we're all following. So go in ed mode, click on that link. If you're using a computer, I think that will be better for you guys. So click on that link.
Sir.
Yes, ma'am.
Okay, I'm in there.
Sir, if you leave the meeting, sir.
It will still be there.
Oh.
Sir, go on the game.
I didn't hear that.
And the link is
Are you yeah, okay, good. I want other persons to let me know if they're on the link.
Yes, sir.
Yes, sir, I'm on the link.
Yes, sir.
I'm on the link now.
Great.
Wait, sir, give me a second.
All right. Now, one of the first thing we're going to do is that we're going to explore different types of force, right? So I want you guys to basically drag one of the characters from the blue team, right? It doesn't matter which one of the character you choose right now. It just means that whenever you choose that character, you need to select the same character for the red team. So you can come back over to my screen on the video to see what I just did a while ago.
Nothing is showing up for me, sir.
I didn't hear that.
Sir, when I go on ed mode, nothing is showing up. Like I cannot see the link.
Oh, maybe ed mode the site is crowded. Sorry about that, man.
Ajay.
But here, what? Nevertheless, come back to to my screen. Come back to my screen.
First.
Come back to persons who are having difficulties.
Sir, come up now, sir.
All right, good. So yeah, if you're having difficulties either way, you can come back to my screen and view what I am doing.
So what do I do? Press the play button, sir, or press download?
Oh, Netflix, okay.
You can download it, or you can press the play button if you want. But no, what I did just now, I dragged my first character to the right side,
Sir.
to the left side. Yes, miss.
Sir, is net force we're supposed to click on, sir?
Yes, net force. Yes, correct. That would be the one you should click on. Yeah, net force. So drag your first character from the blue side and attach it to the string, just like a game of tug of war.
Oh yes.
Then now for the red team, you're gonna drag another character and to the right of your screen.
Yes. So you're the same size.
When you did all of that, you realize that an arrow came up on your screen saying left force, right force. So we expect that the guy in the red is going to pull to the right, and the guy in the blue is going to pull to the left. Now, if you follow the instructions correctly and you choose the same character for both teams, then go to the top of your screen and click sum of forces for me, please.
Sir, it says 0 at the top of the screen.
It says 0. Is everybody there?
Yes, sir.
Yes,
Yes, sir.
Jabari,
No.
what's the total sum force that you have?
0.
0. Good. Now, what do we think is happening there?
The equal force rates balanced.
Okay, all right. Anybody else want to pitch in and say something?
Sir, the force is equal.
All right. Would you say
The
that?
same amount.
Would you say that they're equal, or Coleman? Go ahead. Coleman, you raised your hand a while ago.
Sir.
Coleman, your mic is a little bit low.
I cannot see the link, sir.
You cannot see the link. All right, let's come back over to my page, to the Zoom. Now, we realize that it is 0. But guys, I don't want you to say that the forces are equal. The magnitude of the forces are equal, but the direction is different. So you cannot just say that they're equal. You understand? Because one is going to the right and one is going to the left. Even though the magnitude are equal, the forces are going in opposite direction. Right? Now, our guys, focus on me. Our net force is 0. If our net force is 0, what does that mean in terms of, the operation that is taking place here?
No movement is occurring.
No movement, correct. Anybody want to say something else? By the way, you can hit your go button if you want. Hit your go button and see what happens. Is that how you guys?
Not moving, sir.
Is that how you guys look when you're playing a game of tug of war?
No, sir.
Of course, this is how you would prostrate yourself. But now we're going to add some more characters. So on the blue team, what I'm going to do now, I'm going to bring another character to So bring another character, guys, to your screen for me, please. What do we see happening there?
Sir, press return for the thing to come back there.
All right, let me press return. Yes. So when you added an extra character to the blue team, what did you see happen with the arrows?
Sir, one got longer.
The left arrow is longer because there are more people pulling.
Yes, so more forces, good. More forces will be on this side. Correct. So more forces will be on this side. Now, if you look at the top of your screen, it says sum of forces, and which direction is it pointing towards?
Left.
The left. And we can agree that the left side will win because they have a greater magnitude of force. All right. Now, from a mathematical standpoint, this is how you would do it. So you can go ahead and click value. If you go ahead and click value, you would see where you'd find now what we call the resultant force. The resultant force. Jabari, mute your mic. So the sum of forces is what we call the resultant force, and that is now we doing a subtraction of the different forces, all right, which would give us 100 newtons. All right, so now that we have grasped this aspect, right, we have talked about balanced force. As a matter of fact, I want somebody now to give me a summary in regards to what we did for the first one. Ms. Randall, you had something to say?
No, sir.
All right, persons who raise their hand, go ahead.
Sir.
Right, yes.
So on balanced force, sir, there has equal magnitude and no movement is occurring. And unbalanced force, sir, they have a greater magnitude which causes movement to occur, and one side the sum would be larger than the next side. But when it's equal, but when it's balanced, no sum will be occurring.
Precisely, there will be no movement, and hence you would have a net force of 0. All right.
Yes, sir.
Good. So, guys, in your notebooks, you can go ahead and make your own little notes in regards to balanced forces and unbalanced forces. After which, we're gonna have an activity, right? So you guys will have to do a few calculations and stuff like that and determine whether it's going to be balanced or unbalanced forces. So you guys can come back to my screen now to view the activity.
That's it.
All right, so guys, I have 10 minutes left to finish up this Zoom meeting. So are you seeing my screen, by the way?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So can somebody read the instructions there?
For each of the questions below, identify whether the forces are balanced or unbalanced. Write the resultant force and its direction. The first 2 questions have been completed as examples.
Wonderful. You're such a brilliant reader. All right. Now, the first one is completed for you guys. I think something got chopped off for the first one. So let's move on to the second one, where we see 10 newtons moving to the left, 10 newtons moving to the right. This would be balanced, hence, it would be stationary, meaning that there will be no movement. All right?
Can I ask a question, please?
Go ahead, madam.
Sir, like for the first one, sir, it said 50 newtons, right, sir? But how do you know that if it's unbalanced for the next one?
How do you know if it's unbalanced based on this question here?
No, sir, like for example, number 3, sir, as you can see that the 50 newtons right there and the 40 newtons are the next side, but how do you know the sum?
The sum would really subtracting both numbers. You understand?
Yes, sir.
I think I can do a quick demonstration here. Let me do that very quickly before my screen jumps off. Now, here I have my box. Good? And one force is going in that direction. Now, I must say something to you guys. The length of your arrow determines the magnitude. So in this case, the length would be 5 newtons. Just assuming. Then now based on this length of my vector, that should represent 10 newtons. Now,
nice box, sir.
Thank you. Yeah, I'm good at drawing already. Now, guys, remember yesterday, the first third class yesterday, we were talking about your y and your x-axis. On this side, it will be positive. And on this side, it's going to be negative. Good? So typically, if I'm moving to the left, I should have -5 newtons. If I'm moving to the right, I'm going to have +10 newtons. Now, when I calculate my sum of these two things here, I'm going to get a resultant, which is going to give me a positive number, because if you have +10 minus -5, I'm going to get a positive number. So my answer is going to be +5, which tells me that my resultant is going to go to the right. Are we seeing that?
Yes, sir.
Good. So now that we established this, this is what I want you guys to do for the activity that is here. Where is it now? Yes. So go ahead, guys, and do that for me.
I screenshotted it, so yeah, it's easier for me.
Yeah, what I'm also going to do, I'm going to send it in the Edmodo site, and you guys would submit it.
Edmodo?
Yes, because what I don't want you guys to submit it as a comment where other persons can view your work, because this might as well as go towards, you know, some coursework grade. So what I'm going to ask you guys to do, don't submit it as yet until I get the link for you guys to submit it. All right?
So sir, just set it as an assignment then instead, that nobody will be able to.
Mr. What? What are you saying? Mr. Tate, you understand what's going on?
Yes, sir.
Have you done the number 3 as yet?
Yes, sir.
What's the answer?
Sir, they are unbalanced, so it results in 10 newtons to the left.
Wonderful. 10 newtons, and that's going to go to the left. So you would draw an arrow that points to the left, and we would say it's unbalanced.
Okay, yeah. Yeah.
Wonderful.
Now, sir,
Miss Chin, yes.
Sir, we're supposed to draw the diagram.
No. I'm going to give you everything here in Edmodo, but I just want you to try this one or two in your book.
Number 4?
Yes, who said that? Who asked you to do number 4?
Me, sir.
Go ahead and do it, Jabari.
Jabari, sir.
I said Jabari,
right,
yes.
So since it's 100 newtons to the right, you move the Newton force to the right is larger, so therefore you would move in that direction. So therefore it means that you would subtract the 100 from the 30, which would equal 70 newtons to the right, and it would be an unbalanced force because they're not the same number.
So what's the resultant number again? Tell me again.
70 newtons to the east.
Yes. Good. I would say that's unbalanced.
Yes. Good. So is that a 71?
No, come on, guys. You know it's come on. So that's that's 70.
So petty.
All right. Good. So guys, I want you to complete the rest of it. But I'll send you the link. Sir. Yes, sir.
Just screenshot it.
They're going to post it in something there, Edmodo.
Yes, I'm going to do that because some of it is a little bit chopped off. As you can see, the word would have extended down here. So
there's a Candace write the answers and send it to you.
Miss Lady, I want you to send it whenever I create it.
Whenever I make that, look at me.
Miss Chin, not Miss Chin, Chelsea. I'm going to send you the link where you could submit your answers. Right? I don't want you to comment where persons can see it. Right?
Sir, but what I'm saying, do I have to draw the boxes?
Yes, you should draw the box if you don't have a computer where you can do the thing like that. Guys, I want to also mention to something here in regards to, before we go, for unbalanced force, right? We expect that the directions is going to be not only opposite, but in different directions, meaning that you can also see an unbalanced force like this. So one going upwards and one going in that direction. This would be unbalanced, all right? So not in the typical sense where you'd see it go in the opposite direction. It can also mean like this. It can also be going at an angle. So I just want you to note that as well, that your unbalanced force can go in any direction. You understand? So to speak.
Sir,
yes, sir.
For the example that you show, wouldn't they all be positive?
For this situation here, over here?
Sir.
No. Yeah, it's going to be a positive number, really. But what's going to happen now, you know, the way how to find the resultant is going to be a little bit more trickier than the usual subtraction here, right? So when you reach further in physics now, we will, you know, dive deeper in finding, you know, the hypotenuse and all those kind of things, right?
Okay, sir.
I have 1 minute and a couple seconds remaining. So let's do a quick recap of what we did today, right? So what did we start it off with?
Forces.
Vector quantities.
Oh, I was not here for that.
So we started off initially. No. We didn't start off with vector quantities. Yeah, we did a quick recap on vector quantities.
Forces.
Yes, started off with these images here that would depict, you know, different type of forces in plane.
Excuse me, sir.
Go ahead.
Sir, when the forces are unbalanced and we use arrows to say where they should be placed, what do we do when they are balanced?
You still use the arrows, you know, you still use the arrows, just like how the example that we were doing with the software, right? So you would still use the arrows to show, right? But the resultant, let me say something quickly, the resultant for a balanced force, you would not have an arrow because it is not moving. So I don't know if that's what you're asking me. So seeing that this is balanced, you won't have an arrow. You understand? Because there's no movement. Yeah. All right, guys, that's it really. So we have to take it. We have to end the class here. All right.